Good morning, students. Today we are discuss about meaning of heat. When an object at the higher temperature in the placed in constant with another object at lower temperature, there will be a spontaneous flow of energy from the object. Okay, wow. So next you see uh, at the higher temperature to the one at the lower temperature. So what happened, one object you are kept at the constant temperature, so the temperature what happened, higher to lower temperature, so moving or lower temperature to the higher temperature. This is the energy is called to the heat, right? This process of the energy transferred from higher temperature object to lower temperature object is called heating, right? So that's why I'm saying the process how to we are defined means the object what happens is going to that temperature level is higher to lower to the higher. This is we are called to the that object get the heat. Okay, so due to the flow of heat, sometimes the temperature of the body will increases or sometimes it may not increases. Sometimes what happen, your flow to that heat means what happens, increase to that increase to the temperature level. Sometimes it's not change the temperature level. Okay, so next you see that meaning of work. Okay, now you see you take your hand and rub it. Okay, when you rub your hands against each other, the temperature of the hands increases. You have done some work on your hand by rubbing. So you take your two palm and rub. What happens, you are feel it that some of the heat it's produced. Okay, that times is some of the heat you are observing. Okay, so what means that both the palm is here rubbing, so here at that place they are creating to the friction force. So that force what happens, it's here immediately it's here leave it to that heat. Okay, wow. So that is the temperature of the hands increases due to this work. Now if you place your hands on the chin, the temperature of the chin increases. So immediately your hand, your two palm, you are keep it your chin means whatever the chin observing the your heat in the palm heat. This is because the hands are higher temperature than to the chin. சின்ன விட எப்படி இருக்கும், higher temperature to that your hand. In the above already our body having to some of the temperature. Okay, your two palm you are rubbing means what happens, some of the heat is here increases. Okay, so the same times you are keep your palm, you are keep your chin means what happens is immediately the chin observing to the heat above the palm heat out to means na சின்ன விட பாம்போட ஹீட் எப்படி இருக்கும், இன்க்ரீசபிளாக இருக்கும், ரைட்? ஸோ நெக்ஸ்ட் யூ சி தட் the temperature of hands is increases due to the work and the temperature of the chin is increases due to the heat transfer from the hands to the chin. Okay, so by doing work on the system, the temperature in the system will increases. So and sometimes may not, like heat work is also not a quantity, and through the work energy is a transfer to the system. So we cannot use the word the object contain more work or less work. So we are not defined to that heat is increases now, the object is work is a high, object is the heat is a less means the object is not work. We cannot define that. Okay, it is not. Either the system can be transfer energy to the surrounding by doing work on surrounding, or surrounding may transfer energy to the system by doing work on the system. For the transfer of the energy from one body to another body through the process of the work. So through the process of the work they need not to be at a different temperature. Okay, so next you see that measuring of temperature. How to you are measuring, the two unit we have to using, one is a Celsius, another one is a Fahrenheit, right? So now you see that the temperature is a degree of hotness. The temperature is a degree of hotness or coolness of the body. Hotter the body, higher its a temperature. The temperature will determine the direction of the heat flow when the two bodies are in thermal contact. When the two bodies the thermal contact, that times the what happened, the temperature will be determined the direction of the heat flow. Okay, it is the SI units of temperature is a Kelvin. SI units of temperature is a Kelvin. In our day to day applications, Celsius and Fahrenheit only. Okay, this scales we are used. Temperature is a measure with a thermometer. So the convenience the temperature. Okay, so next you see that a thermal property of matter. Thermal property of matter. So Boyle's law, Charles law and Ideal's law. Now you see some of the principles they are given. The gas at a low pressure kept in the container of the volume. Experiment related the following. Right? You see that first one, Charles law. When the gas kept at the constant temperature, the pressure of the gas is inversely proportional to the volume. Okay, wow. When the gas is kept the constant temperature, when the gas kept the constant temperature, the pressure of the gas is inversely proportional to the, the pressure is inversely proportional to the volume. Right? So we are calculate to the formula P, pressure P inversely proportional to the volume, that is a 1 by V. Okay, so it is discovered by the Robert Boyle. This is discovered by Robert Boyle. This is, so we are telling to that Boyle's law. So next you see that this is known as the Boyle's law in 1627 to the 91. When the gas kept at the constant pressure, the volume of the gas is directly proportional to the absolute temperature. So what happened, first what we are doing that the gas constant temperature. When that gas kept in the constant temperature, that time the pressure inversely proportional to the volume. Okay, this is the Boyle's law. Right? Next, when the gas is kept in that constant pressure, the temperature directly, so that times the temperature directly proportional to the volume. Okay, wow. So volume. So we are taking to that T directly proportional to the volume. Okay. So next it's discovered the Jacques Charles 1743 to 1823. Okay. So this is here we are said to be Charles law. So by combining the two equations, so we are comparing to the two equations, we are get to the PV equal to T. So we have to calculate that C. The C is a constant variable. So PV equal to CT. Okay. So the C is a positive constant. Okay. We can infer that C is a proportional to the number of particles in the gas container. So see how to your calculator means in the gas inside having the number of the particles, small particles. So that is we are calculated in the C. Okay. So if we take two container of the same types of the gas with the same volume and same pressure and same temperature, then gas is each container obey the above equation PV equal to CT. So same temperature, same pressure, same volume, having to that sum of the gas, you are taking the both container, the two container having means, so you are taking to that. Okay. So next you see that so that times we are using to the formula PV equal to CT. Okay. So next you see if the two container of the gas is considered as the single system, then the pressure and the temperature of this combined system will be the same, but volume will be twice and number of the particle will also be doubled. So the temperature is the same, but the particles inside having to some of the particle in the gas. So particles and volume is differ. For this combine the systems, V comes to V. So the C should also double to match with the ideal gas equation P to V by T equal to 2C. So it is implies that the C must depend on the number of the particles. Already we are told number of the particles. So this is a dimension of the PV by T equal to J by K. Okay, Joule by Kelvin. So we can write constant C denoted by K. So equal to the K. C equal to K. So now we are taking to that K. K is a Boltzmann constant. You know that it's a constant value 1.38 into 10 to the power of minus 23 joule by Kelvin. So found the universal constant. It is a universal constant. So now we are determined the ideal gas law. So PV equivalent to NKT. Okay, NKT. Okay, so next you see that the mole is the particle. So Avogadro. Next we are taking to Avogadro. So mole is the particle unit to express the amount of the gas. 1 mole of the any substance is the amount of that substance which contain the Avogadro number, that is a Na, the particles. So now this is here we are taking to the Carnot engine, N0 we are taking, right? So it's defined as the number of the carbon atom contained in the exactly 12 gram of carbons. 12 gram of carbon. Suppose if a gas contains the mu mole of the particle, then the total number of the particle can be written N equal to mu N0. That is Na. So Avogadro number. So Avogadro number, it's a Na is a Avogadro number. It's a constant value 6.023 into 10 to the power of 23 mole inverse. Substitute for the N for the equation. So PV equivalent to mu. So enoda value when the PV equivalent to NKT la substitute pannunga. Enoda value substitute panna. How much we are get to PV equivalent to mu NAKT. This is what that this is here. Carnot engine isothermic la we are taking to this formula, right? Yesterday I told you, no. So okay, now NAK equivalent to you taking to the capital R. So universal gas constant, its a value is 8. So universal gas constant 8.314 joule by mole Kelvin. So the ideal gas law written for mu mole of the gas, PV equivalent to mu RT. PV equivalent to mu RT. So this is called the equation of the state ideal gas that relates the pressure, volume, temperature of the thermodynamic system at the equilibrium. So this formula we are taking to the Carnot engine isothermic process. Okay, I understood. Thank you children. Next class we see.